Hello.
So, what good stuff are we doing? Are you guys on to trig equations yet?
We're actually doing factoring practice right now.
Okay. What do you want to work on tonight?
I'm sending you the pictures soon. My camera will focus.
Okay. If it's just factoring, you could probably read me one or two. We can get started on it.
Yeah. All right. These ones are complicated. The first one is 2 cosine squared x.
Is it an equation?
Yeah, 2 cosine x plus cosine x minus 3. All that is over negative sine squared x. And then equals 2 cosine x plus 3.
Cosine x plus 3 like that?
Yeah. And then over cosine x plus 1. And then the email sent, so you can just probably come in by now.
By the time I had you read it, it was so long that it got there. Hold on a second. Yeah, these are basically trig equations. Okay, I wrote it correctly. Everything's in cosine except the sine squared. Right?
Yep.
Okay. So, let's see. What would the best thing to do here? Well, we can certainly replace this with its identity. So what's the identity of minus sine squared x?
B1 1 minus cosine.
It's the reverse of that. It's cosine squared minus 1. In other words, a minus b is always equal to the negative of b minus a. Good thing to remember. So sine squared equals 1 minus cosine squared, so negative sine squared equals cosine squared minus 1. Just reverse the order. All right. Now, they don't make this easy, do they? No. That's difference of perfect squares. Let's make that say cosine minus 1 times cosine plus 1. Now, that makes it easier, because what can I do now?
Can you start canceling?
Yeah, I can cancel that with that. Now I can multiply the other side by cosine minus 1, so I no longer have any denominators. Let's expand this. We'll have nothing but cosine squareds, cosines, and numbers we can apply the quadratic formula on. In fact, maybe we can just factor this, and we don't have to expand the other. Let's try that. This might factor pretty easily. What is this? What is this going to factor into?
It'll be 2 cosine x plus, or then cosine x, and then plus.
Doesn't factor, does it?
No.
See, if I put the 3 there and the 1 there, yes, it does factor. Now, in other words, what? What are we supposed to do here? What are our instructions? Verify the identities. Oh, okay. Because I was going to say, that's what we got on the other side. In other words, after I factored it, I ended up with the same thing I had over there. Okay, well, I made one mistake here. Or did I? No, I didn't really. In other words, when I canceled those two things out, let me put it back. What was it? Cosine of x plus 1? And I had...
Well, yeah, the denominator was, yeah.
And I'm not allowed to multiply by both sides. In other words, when you're verifying an identity, you have to make the left side look like the right side. You want me to go back and start from scratch on this, or you want to go on to 2? I can go back.
Yeah, sure.
Shall we go to 2?
Yeah, that's...
Because I basically verified it. Although
yeah, let's actually just move to 2.
the one thing you're not supposed to do is multiply both sides of the equation by anything. So,
Okay.
but I did verify that it was equal to that. In this next one, I'll work just with one side. Alright, so sine x over cotangent squared. Cotangent is cosine squared over sine squared. So that would become sine cubed of x over cosine squared. That doesn't seem to get us anywhere. Let's see. If I multiply by the conjugate, then I'm going to have cosecant squared minus 1, which I'll be able to replace with cotangent. And I have a cotangent over here, so that seems like a pretty good strategy. Let's multiply this thing by cosecant x plus 1 over cosecant x plus 1. Okay?
All right.
And never multiply these two together, because you'll just have to take them apart. Okay, the bottom becomes cosecant squared minus 1, which is the same as cotangent squared. Well, what is sine times cosecant?
Sine squared. Or no, 1, sorry. Sorry,
1.
yeah.
In other words, whenever you take a trig function times its reciprocal, it's always 1.
Yeah.
So when I multiply this out, I get 1 plus sine x minus sine x. So the numerator is 1, the denominator is cotan squared, and that's equal to tan squared x. And this probably could have been done a couple of ways. but that seems to be the way that made the most sense, I think. What is sine of pi over 2 minus x equal to?
I don't know.
Cofunction. It's equal to the cosine of x. In other words, the relationship between a function and its cofunction is always this. Tangent of x equals cotangent of 90 degrees minus x. Secant of x equals cosecant of 90 degrees minus x. And vice versa. So whenever you see 90 degrees or pi over 2 minus x, know that that's the same as cosine. So what I can really write here is cosine to the fourth of x. And we have to make all of that equal to 1 minus 2 cosine squared of x. Well, what's that going to be? What's the first thing I'm going to do with that?
Factor that out.
Difference of perfect squares, right?
Yeah.
So sine squared of x minus cosine squared of x times sine squared of x plus cosine squared of x. What's sine squared of x plus cosine squared of x?
Uno.
So now we're down to that. Now, is all we need to do is plug in for sine squared, because we're going to plug in 1 minus cosine squared. Minus another cosine squared gives you 1 minus 2 cosine squareds. Okay, so you're definitely getting a little harder. Okay, when you see a negative x inside, what is cotan of negative x equal to?
Tangent.
No, it's the odd-even property. Negative cotan x. Because cotangent shares the same odd-even functions as tangent does. And tangent is odd, meaning the tangent of minus x equals minus tan of x. So that's the first thing we want to do here, is turn that minus x into something different. Well, we've got cotangent squared cosecant squared minus, in parentheses, a minus cotan of x times a minus cotan of x. Right? In other words, I'm going to take this right here, and I'm going to make it, that would normally have been cotan of negative x times cotan of negative x. Well, that's minus cotan of x times minus cotan of x. So this whole thing becomes positive cotan squared of x. Okay?
Okay.
Well, am I seeing that whole thing as a cotan fourth on the right side?
Yeah.
So this has to equal cotan to the fourth of x. Well, what is cosecant?
What is cosecant?
Mm-hmm.
What do you mean?
In terms of cotan. In other words, right now, we've got a cotan there, a cosecant there, a cotan there, and cotan there. So the easiest way to do this is going to turn this cosecant into cotans. What's the trig identity to turn that into cotan?
Is it 1 plus cosecant equals cotangent, or the other way around?
It's 1 plus cotangent equals cosecant.
Okay.
So cosecant equals 1 plus cotan.
Okay.
Now, we got nothing but cotans that better come out to be cotan of 4. Well, there's a cotan squared, there's the cotan of 4, minus the cotan squared, you end up with cotan 4. That's an important secret in terms of verifying trig, is that when you end up with all cotans and one cosecant, can you turn the cosecant into a cotan? And yes, if you try to think of the identity that allows you to do that. In other words, we could turn that into a lot of stuff. We could turn that into 1 over sine squared. So the trick is to figure out that you want to turn that into cotangents, not 1 over sine squared, because I have nothing but cotangents everywhere else.
Okay. Yeah.
And whenever you see the pi over 2 minus x, you're looking at a cofunction thing. So what can I write instead of that?
You can write tangent of x, or tangent, yeah, tangent.
Tangent of x, exactly. Because the tangent of x is equal to cotan of 90 degrees minus x, and also the cotan is equal to the tan of 90 degrees minus x. In other words, it works both ways. So we got the tangent of x in the numerator. What's in the denominator after we replace that?
Cosecant of x plus cotangent x.
Okay, and somehow that's got to be equal to secant x minus 1. Okay, let's see. Well, could definitely turn the left side into nothing but sines and cosines, and that's probably the way to go. At least that's the only way I can see at the moment. This is 1 over sine plus cosine over sine. Now, the only reason I turned them into sines and cosines is because I can now deal with this and end up probably with a cosine minus 1. In other words, this has to turn into cosine minus 1. Well, let's see if we can do it. I'm sorry, 1 over cosine minus 1 would be required to come up with secant x minus 1. Well, we can certainly add the denominator, right?
Yeah.
So that becomes 1 plus over sine and then if I flip and multiply, I've got sine squared over cosine times 1 plus cosine. Just a second, I'm thinking. Well, sine squared is 1 minus cosine squared, which is 1 minus cosine times 1 plus cosine. Now that 1 plus cosine cancels out with that, and I end up with 1 minus cosine over cosine, which is, splitting it up into two fractions, you get 1 over cosine minus 1, which is secant minus 1. That was a toughie.
Yeah.
Yeah, I don't know that I've had to do that. Turn sine squared into 1 minus cosine squared and then treat that as the difference of perfect squares, such that we can come up with a 1 plus cosine to take care of this denominator. But that worked. All right, let's try this one. Is there anything to the right of that? Oh, yes, there is. There's all kinds of stuff.
Yeah.
What's the number?
Yeah, it's like cosecant squared x plus 1.
Okay. Well, everything's in cosecant except that cotan. Let's turn it into cosecant. What's that equal to in terms of cosecant?
Uh, 1 plus cosecant. Or 1 minus cosecant.
Cosecant minus 1. In other words, cotan squared plus 1 equals cosecant squared. So cotan has to be cosecant squared minus 1. Now, we got everything in cosecant, but we're nowhere near this. Let's try factoring that as the difference of perfect squares. What's it give you?
Cosecant cubed x minus 1, and then cosecant squared x plus 1.
Cubed x plus 1.
Oh, yeah, cubed.
In other words, when we multiply this times this, you add the exponents to get 6.
Yeah.
And that's all over cosecant squared minus 1. Well, what is... We have the sum of cubes and we have the difference of cubes. That'll work. The difference of cubes is equal to what?
Hold on just 1 second, I'll finish writing. What was the question?
Well, now we have the sum of cubes and the difference of cubes. So let's factor those. You know what the difference of cubes is?
It's A, isn't it A, or is that the A plus AB plus B, or A squared plus AB plus...
First one's always the same sign and linear. Second part is always quadratic with the middle term being the opposite sign of that, and it's just AB. It's not 2AB, it's only AB. Okay? So what's this going to become?
Cosecant minus 1. And then cosecant to the, well, that would be to the, okay, yeah, squared, and then plus cosecant, and then plus 1.
And the sum of cubes?
Hold on. The sum of cubes will be cosecant plus 1, and then it will be cosecant squared minus cosecant plus 1.
Okay. And just so we can do some canceling, let's factor the bottom. Cosecant minus 1 times cosecant plus 1. Alright. Now we can cross that out. We can cross that out. And we're left with that times that. And certainly is going to give us the cosecant to the fourth. It's also going to give us, I mean, I haven't multiplied it out yet, but clearly that it's going to give us that. You want me to multiply it out? You know how to multiply a trinomial by a trinomial?
Can you do it? Just
Sure.
for pressure.
Sure. Let me erase everything here but what we're looking at. So, always do these every term by every term. So the first term is cosecant fourth x. That's that times that. Now always do that times that. So minus cosecant third x. And then do the final one plus cosecant squared x. And now do this times that plus cosecant third x. This times that is minus cosecant squared x and plus a cosecant. And then I have to add the 1 multiplied by each. So I'm adding a cosecant squared minus a cosecant plus 1. Okay, here we got a cosecant cubed, cancels out with that cosecant. We got a cosecant squared, cancels out with that. We still have 1 squared left. We got a cosecant, cancels out with that. We end up with cosecant to the fourth plus cosecant squared plus 1. That wasn't really that hard a trig. That was more difficult algebra. In other words, you had to know difference of squares and difference of cubes and sum of cubes. I think. I'm not positive that I had to go to that much trouble, but I couldn't really see any other way of doing it. I don't think I can factor that easily into a cosecant squared minus 1 times something else, although clearly I could divide that into that, and I'm going to get that. The question is, can we do algebraic division here? Actually, you could. You can divide this into that with long division and come up exactly with that. But it's not easy because you have to allow for all powers, and we've only got cosecant to the 6th, so we'd have to put in a dummy variable for the 5th, 4th, 3rd, and so forth. So that wouldn't be that easy to do. This was hard, but doable as long as we knew difference, sum, and all of those. Once we switched the cotangent to some numbers of cosecants. That really was the trick, I think. That's a toughie, but... All right. You good to go?
Yeah.
Okay, good luck. These are tough.
Yeah.
But we did have a couple of new principles here. We had the cofunction principle, and we had the odd-even principle.
All right. Yeah.
All right. Jackson, I will talk to you next time. Whenever that is.
Tomorrow.
Oh, tomorrow. Tomorrow at 5:30. Yeah.
Yeah.
Okay. Talk to you then.
All right. Thank you.
Bye-bye.